first you'll see the pressure drag. So this is the definition. It is formed due to the pressure imbalance caused by the flow separation. You know, due to the shear stress or friction, the flow on the surface will lose its kinetic energy at some point. From that point onwards, it will separate. So here we have high pressure stagnation, and this side we have some low pressure. Okay, so this flow separation causes the wake region and some low pressure region. Because of this, we are getting the pressure imbalance along this flow direction. Okay, due to this pressure imbalance, that is high pressure to low pressure, we are getting the drag. That is called pressure drag. Is it clear?
Yes, sir.
Okay. Next one is skin friction drag. This is due to the frictional shear stress. Okay. So due to the flow interaction between flow and the wall, there is a buildup of shear stress. Because of that, we are getting the drag that is called skin friction drag. You can see if the object is very thin, then the full drag is due to the skin friction. Okay, because here and here, if you see, there is a negligible amount of pressure difference because there is no much separation. As it is very thin, the flow may be very smooth. Okay, there is no separation, there is no pressure difference. So the pressure drag or form drag is zero. Only skin friction drag is there. And if you increase the thickness little bit, then there will be a small separation, small low pressure region, then small pressure difference. So we are getting around 10% of the pressure drag, and remaining drag is due to the skin friction, due to the friction between flow and the wall. And if you take bluff body, okay, that is very thick object, then here the flow may be attached from here to here. Okay, because of this flow attachment, we are getting 10% of the skin friction drag, and remaining drag is due to this large wake. Okay, so 90% is due to the pressure drag in the bluff bodies. And here you see it is completely separated. Only this small region the flow may be attached, but it is not attached. Only in the corner it may be attached. So it is negligible. So skin friction is zero, and the pressure is mainly due to the flow separation. So if the object is very thin, then the majority of the drag is due to the skin friction. Okay, if the object is very thin, the majority of the drag is due to skin friction. And if you increase the thickness, then the contribution of pressure drag also will increase. At last, for the bluff body, the majority of the drag is due to the pressure. Is it clear?
Yes, sir.
So two types we discussed, pressure drag and skin friction drag. Then profile drag. The profile drag means the drag of an airfoil. Okay, that is sum of pressure and skin friction. Okay, pressure drag plus skin friction drag. If you add, that will be the profile drag. Profile drag means drag of the airfoil. The next one is interference. So here the definition is, this is due to the interaction flow between each components. So there may be a flow over the fuselage. That disturbed flow may flow over the wing. Again, there may be a disturbed flow from this wing that may flow over the wing. From the engine, the disturbed flow may be flowing over the wing like that. There may be a lot of interaction of flow. Due to that, we are getting additional pressure drag. That is called interference drag. Okay. So here I can explain. You see, without this propeller, the flow is smooth on the airfoil. So here we may have the less drag. But see here, because of this rotating propeller, we are having the disturbed flow. So that disturbed flow affects the flow over the airfoil, so the drag is increased. Okay, similarly here also you see the propeller, how it affects the uniform flow on the wing. So it is completely affecting. Here also you see this engine, it disturbs the flow over the wing. So we are getting the disturbed flow on the wing, so the drag is increasing. Here also the fuselage, this leading edge root extension, everything disturbs the flow over the wing. And here you see here the landing gear. So the landing gear also disturbs the flow over the complete aircraft. So all this interaction flow increases the additional pressure drag. So here the fuselage. Okay, so because of this interaction of flow, we are getting additional pressure drag, that is called interference drag. Okay, so profile drag means it is for the airfoil profile. Okay, you know, due to this friction between these two, we are getting skin friction. Due to the separation, we are getting pressure. Sum of these two things is for the total drag of the airfoil profile drag. Then interference, interaction flow between all the components. Then parasite drag. So parasite drag means for the complete airplane. Okay, so here we are adding pressure drag, skin friction drag, and this interference. Okay, so all those things, if you add, we can get the complete airplane drag, that is called parasite drag. Okay, but this is the what is that very old definition. Nowadays, as I told, there are 10, 20, even 30 components of small drags they are including. If you want to find accurately drag over the aircraft, we have to take more number of components. So here itself they mention, you see, flap drag, tail drag, nasal drag, like that n number of drags we have to include it accurately if you want to find the drag of an aircraft. But this is the general one: pressure, skin friction, and interference. Okay, so definition of parasite drag is pressure plus skin friction plus interference. This is for the complete airplane. Is that clear? This slide.
Yes, sir.
So induced drag already discussed. So due to the wingtip vortices, so we are getting the additional drag. You can see here. So this is the total force, lift force. It is acting on the okay, wing or aerofoil, but without this wingtip vortices. Because of this wingtip vortices, what happens? It decreases the angle of attack. We will discuss in the second unit. Okay, so this wingtip vortices produces the downwards region in the center of the airplane or in the wing. So due to that, this downward component affects the free stream flow. So this free stream flow deflected downwards. Because of this downward deflection, the angle of attack is reduced. If angle of attack is reduced, lift also will be reduced. So previously this is the magnitude. Now the magnitude is reduced like this. Okay. So we are getting additional and original component, that is called induced drag. So wingtip produces the additional drag that we are calling as the induced drag. So all these force diagram, etc., and all we will study in the second unit. Is that clear? So leave this force component, simply outright due to the wingtip vortices. So we are getting the additional drag, that is called induced drag. That much is enough. If you want, you can draw this diagram. This clear, right? Hello?
Yes, sir. Clear.
And wave drag also already discussed. So if you take subsonic flow number, the Mach number, the flow may be accelerated to maybe 0.6 or 0.7. If you further increase the Mach number from 0.5 to 0.7, assume the Mach number reaches 1. Once the flow reaches sonic and anywhere on the airfoil, then the corresponding free stream Mach number is the critical Mach number. For example, if this is the 62012 airfoil, then Mach number 0.72 is the critical Mach number for this airfoil. And this Mach number we will get the sonic flow. And if you further increase the Mach number from 0.72 to 0.77, so here already it reached 1. So here it may reach 1 or 1.1 or 1.2 something. Okay, that is supersonic region. So this is the supersonic region. So here we have low pressure, but here we have the high pressure because of sonic flow. So to adapt this pressure difference, nature creates the normal shock wave. Okay, the nature of normal shock wave is converting so low pressure to high pressure. It's a compression wave. So here we have the high pressure now, and here we have the atmospheric pressure. Due to this pressure difference, they are getting additional drag. That is called wave drag. Okay, so additional pressure drag caused by the shock wave is the wave drag. And if you further increase the free stream Mach number from 0.77 to 0.88, so this wave so will move towards the trailing edge. You can see, or 0.88 from here to here it moved. Same time, in the bottom side also, the flow is accelerating to the supersonic. So previously, only on the upper surface, it reached the supersonic. Now, if you further increase, bottom surface also, there may be a supersonic region, there may be a small shock wave. And further, if you increase, at last, both shock waves will be at the trailing edge. Okay, so near the trailing edge. And if you further increase from 0.95 to 1.05, you know this is supersonic, right? Subsonic means Mach number less than 1. Sonic means Mach number is equal to 1. Supersonic means Mach number greater than 1. So here it is completely supersonic, 1.05. So what happened? We are getting another one additional bow shock. So till that, so this is subsonic, there is no wave. So this is critical Mach number. Only in some region we are getting m is equal to 1. And after critical Mach number, there is a local supersonic region, shock wave. If you further increase, it will move towards the trailing edge. And in the bottom also, there will be a supersonic region. At last, both shock waves will be in the trailing edge. Okay. And if you further increase, up to this, it is subsonic only. Okay. See, Mach number is less than 1. And once it is supersonic, there will be additional wave in the front. That is called bow shock. Okay. So bow shock is the combination of waves. In the center, it is like the normal shock. And this inclination shock is called oblique shock. And this is called Mach wave. These things are all you study in aerodynamics too. Is that clear? But in this topic, wave drag, you can simply write additional pressure drag caused by the normal shock. Definitely is enough. Just for your understanding, I am giving extra information. These things are not necessary for the exam point of view. Is that okay?
Yes, sir.
Then zero lift drag and drag due to lift. So zero lift drag definition is when the aircraft is at zero lift angle of attack. Okay, it may be 0 or it may be minus 2 degree, 3 degree. Okay, the condition is total lift produced by this aircraft should be 0. Okay, if the aircraft is at zero lift angle of attack, then the corresponding drag is called zero lift drag. Okay, even though the aircraft produces zero lift, definitely there will be a drag wave, right? Due to the pressure and motion contribution. Assume it is 10 Newton. The 10 Newton is called zero lift drag. The definition is when the aircraft is at zero lift angle of attack, then the corresponding drag is called the zero lift drag. Is that clear?
Yes, sir.
Then drag due to lift. Now assume same aircraft, I'm increasing the angle of attack, some positive angle, so that I'm getting some lift value. Assume from minus 2 to 10 degree increased. Because of this 10 degree angle of attack, I'm getting lift of 100 Newton. If lift increases, drag also will increase. So I'm getting the drag of the aircraft is 22 Newton. Okay. So previously at 0 degree, that is 0 lift drag is 10 Newton. Because of this 10 degree angle of attack, the drag is increased to 22 and increment in drag is 12. Okay, 22 minus 10 is 12. This increment in drag is called drag due to lift. So I increase the angle of attack, lift increased from 0 to 100, drag also increased from 10 to 22, and the increment is called drag due to lift. So here the increment is 12 Newton. So here the definition is, so drag due to lift. So this is also a, what is it? It's additional pressure drag, but it is measured above the zero lift drag. Okay, so additional pressure drag, which is measured above the zero lift drag. Is it clear? Should I repeat?
Yes, sir. Clear.
Okay. So here, just an approximate information I got it. So if you take a complete aircraft, you see, so the most of the drag is due to the pressure because you know the shape. Okay. So there are a lot of interaction, etc. and all. So lot of pressure components. So 55% of the total drag is due to the farm drag, and 17% is due to the interference, and 12% is due to the internal flow. You may take this engine, etc. and all. Okay, so the engine also causes some drag. Okay, flow through engine also causes some drag. The type of internal drag, it is 12%. Then surface drag, that is skin friction drag, is 9%. Then lift drag,